Welcome back, guys. So, I know that this is not an official, new content type video, but in this, I'm going to try my best to go through an example. That's going to have a ton of parts, and I get that, but welcome to the AP test. But my goal here is to just kind of jog your memory on a bunch of stuff that we've covered this year. So, what I would do is each time I flip to a new slide, I would pause the video, read through it yourself, and see if you're capable of answering these questions on your own. Now, as always, I'm going to be going through the questions, but you got to make sure you're listening to what I'm saying because I'm not going to write down a lot of these answers because it would just be a lot of me with really, really sloppy handwriting on the screen. So a lot of it I'm just going to be talking through, and I'm not going to give you like just one set answer, but instead answer with a huge range of answers that you could give to answer this type of question using stuff we've covered in this class. All right. So we're going to go through step by step on this. Each slide is kind of going to hit a different major topic we've covered in this class, but it's going to follow along the same mindset for the question all the way through. And I'm sure that this will be what the actual AP questions are like, where they give you one situation and kind of ask you to just hit on multiple things as you go along with it. So that's what I'm trying to attempt here. I'm trying to hit as much of the information that we've covered this year as possible. So with that said, let's go ahead and start off. It says, probability and statistics classes have become a popular option for year 4 of math instead of the usual pre-calc option. That's PR, it should be pre. Today, let's explore some data from the grades of probability and statistics across the nation. You've been given the task of collecting random student grades from across the nation. This raw data includes thousands and thousands of students and can be separated by their area, their race, their gender, and their age. Describe how you would collect a simple random sample of 500 students from this list. Now, again, if you want to try this on your own, go ahead and pause at this point and write down your answer. If you'd rather me just give you the answer, then here's what I would say. Simple random sample was the first of multiple types of random sampling that we covered. This was the one where essentially you assign everyone a number and everyone has an equal chance of being drawn. Now, there are multiple ways of doing that. You can either use a random number generator, if that's on your calculator, or if that is in your computer or whatever, or you can use a random number table like those found in the back of your book or in the formula sheet that they usually provide with the AP test. So in this case, you really just have to list out two major things. Number one, you have to mention the fact that you are assigning a number or some type of thing to all the people. And number two, describe the random way in which you would pick those numbers. So simply here, I would say, I would go ahead and through my thousands and thousands of students, I would assign a number to every student. And then I would use a random number generator, such as my calculator, to randomly pick 500 students from that list. And I would ignore any repeats. Now remember, the little ignore repeats thing is another little tagline that you usually want to throw in. That's the definition of a simple random sample. So you don't have to make it any more difficult than that. The second part is where we move into a bit more with the definitions because there's more to it. It says describe another sample method that would guarantee a mix of student types yet still be random. So in our simple random sample, it is possible that we could have randomly chose 500 students from the list and almost all 500 happen to be men. Now, it's very unlikely, but it's possible. It could turn out that out of those 500, they all ended up being white. Rare, but possible. So this second one saying, is there a way that would guarantee a mix of the types of students? Now, we did have 3 other types of sampling that was considered to be random. The first one was stratified, where we put them in groups based off of a common feature, and then we randomly select some from each group. Then there was cluster, where we randomly place them in groups and then sample entire groups to make up our sample. Now, that one, unfortunately, still doesn't separate them by a specific type, which means we're not going to be guaranteed a mix. All right. So it's possible that maybe we would get all students from one area and they just happen to be all the same race from that area. So we don't really have a mix of students. So cluster would not be the type of sampling they're looking for in this case. The other type we talked about is systematic, where you define a formula and then you randomly select your first person in the list and then follow your formula like every other person or every 100th person or every 50th person, and you pick your people like that because you're not choosing the way the list is set up. So by following your system, there's still an element of randomness to it. Now, that again can't guarantee that you get a mix of all student types. So the way you would have to do this one is the first one we mentioned, stratified. So how would I write out a stratified answer? I'd put something like this. I'd say, all right, so it's already separated by area, race, gender, and age. So I might pick one, two, or three of those and kind of describe, first off, I would separate them into strata, which is the way in which you're putting them in groups, based off of race. So maybe, I don't know, let's say it says here, describe another sample method you would use to guarantee a mix of student types. It'd still be random. So I would say, I would use a stratified sample by first placing all students in strata based off of their race. Then I would assign numbers to each student within each strata and randomly select some students from each group. Now, that number doesn't have to be the same for each group, because if, let's say, for example, 40% of my students are African American, then I probably want 40% of my sample to be African American. So I can just make sure that if I want 500 students total, then I'd just do 0.40 times 500, and that would tell me how many randomly selected students I would have for my African American subgroup. So this would be a stratified sample, and this is what you have to describe. So first off, you would have to label it as stratified. Second off, you would have to make sure that you talk about what strata you separated them by. In my case, I said race. You can also choose to do it by multiple. And then you would need to make sure you mention that you give each student within each strata either a number or name, whatever. And then you last have to talk about how you would randomly select students from each strata using those names or numbers. So you would make sure to have all of those things in there. So just like before with simple random, you want to make sure that you hit the fact that it gives everyone a name or a number. You want to talk about how you would randomly generate the numbers based off of either a random number generator or the tables in the back of the book, and you would mention no repeats. Just like that here, you would mention the fact that you are using stratified. You would split them into your strata and say how you're doing that, by which thing. Then you would talk about assigning the names or numbers, and then talk about how you randomly pick those names or numbers. And you can even throw in, for laughs and giggles, the fact that you would ignore repeats. Cool? Let's go ahead and move on to our next slide. So again, now that we're on a new slide, if you want to read through this and try to do it first on your own, now would be the time to pause it. Cool. So I'm going to go ahead and go through this. Essentially, the situation is still the same, looking at grades from probability and statistics across the nation. But it says below, we have the results of 50 randomly selected students and their final grades in the class. Please describe this distribution. So this is a one variable because we're only looking at the grades, piece of data. Now, there are 50 people in this sample, all right, and they give you the summary statistics over here on the left-hand side, and they give you the graph itself, the histogram over here on the right-hand side. You might not be able to see everything down below. Let's move this up here, and I'll go ahead and minimize this guy so you can kind of see these little numbers down here that are super, super tiny. But let's talk about what things. If you're asked to describe a one variable distribution, what things must you talk about? There's four of them, and they're actually on the board behind me. I'm not sure if you guys can see all the way over there. But it says for one variable, you need to do shape, center, spread, and unusual features. So if you do not list all four of those things, you're not going to get full credit. So always make sure you're hitting your shape, your center, your spread, and your unusual features. Now, the first thing to talk about is shape. If I'm looking at this guy right here, our major shape words that we've used are either skewed left, skewed right, bell-shaped, uniform, meaning straight across, or we might use specific things like unimodal, meaning that it only has like one peak, or bimodal, where it has two peaks, or multimodal, where the peaks are kind of all over the place and there's not just one or two of them. In this case, because we are high on the right-hand side and slowly drift down off to the left, we would call this graph skewed left. So if I were to be talking about my shape, I would probably say this is a unimodal skewed left graph, which means it's non-symmetrical because it's not the same if I were to cut it down the middle. So we went ahead and said it was skewed left. Now that knocks out our shape. Next, we need our center. Now, there are two things that usually describe our center. You can either use the mean of the graph, or that's also known as x bar when we're dealing with samples, or you can deal with the median of the graph. And remember, the median is the middle number. And we've actually discussed when you use which one. So you want to use the mean if your original data is symmetrical or bell-shaped, whereas you want to use your median anytime you're dealing with an extreme skewed left or skewed right, or the data is just not as beautiful and it has a whole bunch of outliers or something like that. So in this case, we would want to choose the median since we have already defined that this is skewed left. It wouldn't hurt to mention what the mean is, but I would make sure you have the median to show that because it's skewed left, we want to discuss the center of the median being a 79%. That's in your summary statistics, so you don't have to guess it by trying to come down here and find that the middle is right here at 79. That would be pretty hard to do, but they give you the median, so don't do that, all right? So you would say it has a median of 79. That's our center. We're done with that. So that was our center. And we're moving on now to our shape center and spread. Spread is usually measured in one of two ways, with a third little not as useful one. So our two ways we talked about is either using the standard deviation or using our IQR. Okay, so usually for spread, you're talking about how spread out your data is. That's usually measured in either your standard deviation or IQR. And just like before, standard deviation is used when it's bell-shaped and symmetrical, and your IQR is used when it is not as beautiful, so skewed left, skewed right, or a whole bunch of outliers. How do we find IQR? Because that's the one we're using here, since it's skewed left. How do we find IQR? IQR is just your Q3 minus your Q1. So in this case, 87 minus 70. So you would just go ahead and plug that in your calculator or do it in your head to get that that is 17. So in this case, we would say that the IQR of this graph is 17, which is the definition of our spread. All right. You could still mention the standard deviation, but in this case, because it's skewed left, we go with our IQR. The last thing we want to talk about is our unusual features. In this case, there are no unusual features. I would still probably list that because we do not see any outliers and we do not see any gaps by simply looking at this information. So by looking at it, we would not see any obvious outliers or gaps in our information. Now, you could argue that there may still be an outlier over here. We just don't know it. So an easy way to kind of get around that non-committal type answer is by saying there are no clear outliers by looking at the graph. Cool? That's going to wrap it up for this slide. So just make sure if they ask you to describe a one variable statistic, that you are mentioning shape, center, spread, and your unusual features. Let's move on to the next one. So this is going to be the slide that we really start diving into our calculator work here. But again, because we're on a new slide, feel free to go ahead and pause the video here, see if you can read through the questions and answer them on your own. So let's see what we got as an answer here. It says, what score would a student need to not fall in the bottom 25% of students? Now, there are two ways you can do this. The first one would be the long way of plugging this all into the calculator and finding out what is inverse norm of 0.25 using the mean and standard deviation from this situation and getting your answer. We're going to be doing enough of like the norm CDF, inverse norm stuff in a little bit, but that's a waste of your time here. This should be a quick question. And if you're going through all of those things, you're going to fall behind, which means how would you go about doing this? Well, I know that when I look at my Q1, my median, and my Q3, it separates my data into four pieces. And each of those pieces is exactly 25% of all of my data, which means if I don't want to fall in the bottom 25%, that just means I need to get a grade equal to or larger than my Q1, which means the answer to this first question is simply 70. So you would need to get a 70 or higher to make sure you're not in the bottom 25%. Second question says, would a student that got a 52% in the class be an outlier or unusual? I put both of them on there because those are the two usual terms that an AP test will use. It'll either ask you about something being unusual, or it'll flat out use the definition of outlier. Like it'll say, oh, is this an outlier? We have two major ways in my class that we have covered deciding if something is an outlier or not. The first way was by using our IQR. And there was a formula that said you took Q1 minus star and you took Q3 plus star. And if a number falls outside of those two numbers, then it would be considered an outlier. Now, what is star in this case? Star is just 1.5 times your IQR. So in this case, what would that number be? That number would be, first off, Q1. I'm going to do this work right up here at the top. But that would be Q1, which is 70, minus IQR times 1.5. Now, we already said that IQR was the 87 minus 70, which gave us 17. So let's flip over here and go ahead and put in 17 times 1.5. Enter. 25.5. So that means that my two things are going to be 70 minus 25.5. And we want 87 plus 25.5. All right. So if I go back over here, again, that's going to be 70 minus that answer, which was 25.5. And we want 87 plus that 25.5, and that gives us 112.5. So in other words, in order to tell if something would be an outlier, it would have to be either below 44.5 or above 112.5. So if we go back to the question, it says, would a student that got a 52% be an outlier? Well, by that definition, 52% is above 44.5. So it is not an outlier because it is not outside of our range. So again, we got 44.5 and 112.5, 112.5. All right. So we did not fall outside of this range. If we were outside of these two numbers, we'd be an outlier. We were not, so it's not unusual. The second way we've talked about doing this is by taking your mean and adding or subtracting your standard deviation 2 times in either direction. Now, obviously, 52 is on the lower end, so I'm going to save my time from doing both of them and just take the mean minus the standard deviation twice. So in this case, our formulas that we usually used for this used our population standard deviation. But notice the two of these are extremely close. Remember, this symbol means population standard deviation, and this symbol means your sample standard deviation. So which one would you use in this case? I really don't think there is a clear answer to that. Some of the other ones will be a little bit more firm in what we will use for that. But in this case, because all of this information is coming from a sample, I'm going to go ahead and just use the bottom one of 10.66, just so that I'm consistent with the fact that all of this information came from a sample and not the population. So let's go ahead and do this. We got 10.66 is what we're going to use as the round. Our mean in this case was 78.58. So 78.58. And remember, what I'm going to do here is subtract the standard deviation, that 10.66, twice. So I'm going to subtract 10.66, and I'm going to subtract 10.66 again. Now notice I did A and S, which means it takes this answer and subtracts the 10.6 again. So I go ahead and subtract 10.66 the second time, and this tells me that two standard deviations below the mean would be 57.26. So if I look at 57.26, that means that this actually would be pretty unusual. Now, remember, in order to be super unusual, we would say that it's 3 standard deviations away, and that's like extremely rare. So in that case, we would again subtract another 10.66, and that would actually put us below the 52 mark. So this is not extremely unusual, but it actually is unusual by using the standard deviation method. Because it did not define which outlier method to use, there is no right answer, one versus the other, but it is always useful to show your work. In this case, it would not be okay to just say, yes, it is an outlier, or no, it's not an outlier, because as you guys saw, when we did 70 minus the 25.5, the IQR method, we actually found out that this is not an outlier. But when we did the 2 standard deviation method, we actually found out that it was lower than 2 standard deviations away from the middle. So when we're looking at this, the method you're using depends on which answer, or sorry, will give you one answer or the other. So don't get stuck in just saying like there's only one right answer here. Just make sure you clearly show your work and clearly choose a method that you are using to get that answer. So in this case, you could either use the 1.5 times IQR subtracted from the Q1, or you could subtract the standard deviation twice from your mean. Now, with that said, let's move on to our next question. What would the probability of a student getting a 69% or less in this class be? So if this is the case, we're looking at 69% or less probability question. We do not have a normal curve. All right. So it is hard for us to say that using a normal PDF in this case would be very useful, or CDF. But we don't have any better method of doing it. So if this is all they gave us, our best method would probably still be to use our normal CDF, only because we are not given any better method to use for it. So I would probably say that it is about, just because of the whole fact that it's not. So maybe I would say proceed with caution. Heck, we all know what that means. And I would jump over here, go into my menu, and remember, when we want to find probabilities of a normal distribution, in other words, find out what percent of the population or what's the probability that you would fall above or below a certain number, we always go to normal CDF. If we want to find the exact one number, we would go to PDF. And this is not even including all of this stuff on like binomial and geometric and all of that jazz. But for right now, let's just go ahead. We'll do normal CDF. Lower bound, we want to go from that all the way up to, what did it say here? We want to go up to probability of getting a 69% or less. So I'm going to go up to a 69. And then we would plug in our mean and standard deviation. Again, because we are dealing with a sample of stuff, I'm going to use the S. So let's do our 78.58. 78.58. And our 10.66 for our standard deviation. So we hit OK. And it tells us that there's an 18.441% chance of getting that to happen. So if I go back over here I can go ahead and plug that in. Whoa, it gave us a bunch of numbers there. But it is approximately 18.44%. I'm not sure what these numbers down here. It might actually be an extension of this guy. Let's see. Yes, it is. So that's just a very, very long rounded answer. Now, again, be careful because as we stated, this is not necessarily a normal curve, but this would be the closest we have to doing it. The next question is very similar. It says again, what's probability of doing it, except this time it says between a 70 and 80. So when I go in this time and hit my menu, let's go to, why not, statistics, distribution. Look, you can go multiple ways. Here it is, still here, normal CDF. In this case, we want to know going from 70 to 80. So I'm going to get rid of that guy and put in my 70. I'm going to put in my 80. We know that it's 78 point, what was it? 78.58. And this guy was our 10.66. And I go ahead and hit OK. It turns out that, oh, it didn't even do it. I think it's probably because my cursor was not where it needed to be. If you do have something highlighted on here, sometimes it does that to you. So let's, again, just put that in very quickly. Menu, stats, distributions, normal CDF. We went from, I forgot what it was again, 70 to 80. It was 78.58 and 10.66. Hit OK, and your answer would be 34.2541%. So in this case, there's a 34% chance of it being between those two numbers. All right. So that would be our answer down here. That knocks out our last one for this question, and we're able to move on to the next slide. All right, so again, go ahead now, since we're on a new slide, pause the video and attempt doing it on your own. All right, so if you read through this, we're looking at confidence intervals. So it says here that if you were talking to a new district that was considering province stat, what confidence interval would you give for the average grade in the class? So we've now moved on to looking at an average grade in the class, not one individual. So remember, for a confidence interval, there's two major parts we're going to do here. First part is going to be making sure we check our condition. Second part is going to be plugging it into our calculator. So what conditions work for this? Well, again, we need to define what test, or in this case, confidence interval, we're going to use. We are basing all of this information off of a sample. So in that case, it tells me that even though we have this guy, it was calculated from a sample, which means this is not the true population standard deviation. So we would not use a Z interval. We're actually going to use a one sample, whoa, T interval. And that's going to come to be important here in a second. But I write this down because it's important for the AP reader to know which interval test you're using, all right? So you always want to write down what it is. So this is my one sample T interval. And remember, we use Z intervals when we have the population standard deviation or if we're dealing with proportions. But because this is a sample that we have a mean and standard deviation from, we're actually going to use our T interval. Now, once we do that, we can check our conditions. So number one, random. Yes, this was randomly selected. So that's a check mark for the first one. Randomly selected because remember back in the very beginning of this question, it said that they randomly selected 50 students. So we're good for that one. Next one is the 10% condition, which is also a check. The reason being is remember 10% says that our sample size is less than 10% of all the people in the population. There's a lot more than 50 people taking this class. So across the nation, this is way under the 10%. We don't have to worry about that one at all. The last one is the large enough or nearly normal condition. And we're going to check that one off as well because we are now dealing with sampling distribution since we're looking at the probability of an average being somewhere for our confidence interval. which means we can use a variation of the central limit theorem to say that a sample size of 50 is going to essentially make our sampling distribution a normal curve. In this case, that means that we will fulfill the nearly normal large enough sample size condition. So the conditions are all met, which means we are ready to start plugging this into our calculator. So how do we do a confidence interval for the calculator? We go to menu. We will go to statistics, our confidence interval. We already said it's the t interval, all right? And we don't have data here. We have the stats. And let's just plug in what we got. Remember, what was the mean for this? It was 78.58. What was the standard deviation? That's our 10.66. And our sample size was 50. The question itself did not tell us what level of confidence we're using. So we'll go ahead and stick with the default of 95. Remember, you could also do a typical 90% confidence or a 99% confidence are the two other usual ones that you do there. So we're going to hit OK there, and we want our C lower and our C upper, which are these two. Let's go ahead and bring them over here. Whoa, moved up there. So we're going to pull this guy down. All right. And it says here that our lower is 75.55, our upper is 81.61 if you round. So I would say if I was looking at a new district that, hey, if you're giving out problem stats, I bet you that if you look at all the students that take that class, the average grade that all of your students would have for that class would be somewhere between a 75.55% and an 81.61%. And I can say that with 95% confidence. Another way you could word that is with 99% confidence, I believe the true mean to be between 75.55 and an 81.61 would be the official verbiage that we would be giving for this. All right. So that actually is all for your confidence interval. That's all they were asking is what would you expect them to get? That's a confidence interval question. So there you have it. Let's move on to the next slide. Another person comes up and claims that they also took a random sample of 100 students and got a mean of 72 with a sample standard deviation of 12. Is this enough evidence to show that the original study was wrong? All right, so if we're trying to show if something was right or wrong, this sounds like a hypothesis test. At this point, go ahead and pause the video and try doing this hypothesis test on your own. All right, so if we follow through our 7 steps, all right, the first one we need to do is check conditions. Now, here's the great thing about this. It's still based off a sample of 100 students, all right, and we have a sample standard deviation of that sample, which means, again, we are going to be dealing with the one sample t-test. Now, here's the deal about this. The condition for a one sample t-test is the same as the conditions for a one sample t-interval, which means we already know that it fulfills the random rule, it fulfills the 10%, and it fulfills the nearly normal with a large enough sample size. So we don't have to go through those again now because I just showed that they already met the conditions. I may want to mention it though that, hey, we already know the conditions are met by the same argument as above. You do have a different sample size here of 100, but again, 100 is still going to be less than 10% of all students that take problem stat. So at this point, it comes down to identifying what information we've been given. We have 100 students. The average of that mean was 72 with a standard deviation of 12. We need to write our HO and HA. So HO and HA are null hypothesis and our alternative hypothesis. Now, in this case, we're dealing with means, so we're going to use the mu over here. And remember, HO always has your equal sign. And it says that we want to know, is there enough evidence to show the original study was wrong? It doesn't say that it was above or below. It just says the original study was wrong. Well, what was the mean for the original study? It was 78.58. And we want to show that it was wrong. In other words, it is not 78.58. And we will use this sample information of a mean of 72 with a standard deviation of 12 from 100 students to try to prove if this is right or wrong. Now, they didn't give us an alpha, so we're going to go ahead and have to set our own alpha. Again, we're going to use the default of 5%, which is essentially the opposite of 95%. You also could use a 1 or a 10% or the other two common ones, but because it's not mentioned, we're just going to use the most common one of the 5%. At this point, I'm ready to plug it into my calculator so that I can get my p-val, all right? So I go into my calculator, we go into, let's make sure we're clicked down here, menu, we want to go to the statistics, stats test, and we're going to do a one sample t-test. We're going to go ahead and switch it to stats, hit OK. And we already said that the mean in our HO was 78.58. The sample mean was 72. The standard deviation for the sample was 12, and the sample size was 100. And we're trying to prove that it's just not equal to the 78.58. So we hit OK, and we find out that our p-value is this. What does this mean? Now, I chose this one purposely so it would throw us a little off game with something we haven't seen before. If you ever see this e to the -7, that essentially means that the decimal place has been moved over 7 times from over here. So the decimal was like 0 point and it had a bunch of zeros and then here. So if I move this over 7 places again, it's really going to be 0.6 zeros, then 319751. In other words, this is an extremely small answer. So that would be 1, 2, 3, 4, 5, 6, and then it's going to start at the 3, whatever it was, 19751. So this number is, remember, our p-value. I probably should have just written that down there. P-value, and it is far, far smaller than our alpha. So remember, if your p-value is smaller than alpha, that means the chances of this happening is so rare, it should never have happened, and we can actually reject the original statement and accept the alternative. So in this case, we reject the hell that the mean was 78.58, and we're able to accept the alternative that it was not equal to that percentage, okay? So this was just a standalone hypothesis test type question. We're going to look at one other slide that is going to be very similar to this one. New slide, new problem. So go ahead and pause it right here and see if you can figure this out on your own. All right, so if not, let's go ahead and look at it together. It says, it was stated that the province stat has a higher average score than a pre-calc class would. After randomly sampling 200 students, 100 students in province stat had an average score of 76 with a sample standard deviation of 10%, and the 100 students in pre-calc had an average score of 71% with a sample standard deviation of 13. Is this enough evidence to support the claim that the average score for province stat is higher than the average score for a pre-calc class? All right, so we have to go ahead and look through these. Because we're trying to prove something to be true, we are again looking at a hypothesis test. But in this case, we are dealing with a two sample because we have the province stat people and the pre-calc people. We're looking at a two sample t-test. And the reason that we are dealing with a t-test still is because of the fact that we still are dealing with sample standard deviations, not a population standard deviation. So this is a two sample t-test. Now, the conditions for this is actually going to be very similar. We're still going to look at random, which it says right here, randomly sampled. So there, first one's checked off. We're still going to look at 10%, 100 students, another 100 students, still not 10% of all students that take province stat and calc. So that's going to be our second check, all right, with the sample size being 10% or less. The nearly normal is still going to work off the same argument. The only one that we're really checking new here, all right, check that last one. New here is going to be the independent group. In other words, what a student gets in province stat is not going to affect the students in what they get in pre-calc. You would not assume that one class is going to like ruin or help the scores of another. So in this case, I would claim that they are indeed independent groups of each other. So we meet all four conditions and we're ready to move forward with our stuff. So let's talk about what our HO and our HA would be in this case. Now, what's the final thing say? It says Is this enough evidence to support the claim that the average score for prob and stat is higher? Now, there are two ways we usually write two-sample t-test statistical stuff, okay? First off, let's define prob and stat as one, and we'll define the pre-calc class as two. So in other words, what we're saying here is that the mean of prob and stat is assumed to be the same as the mean of pre-calc. We want to show that the mean is actually higher in a prob and stat class than the mean of a pre-calc class. Now, a second way you could write this is by saying that mean one minus the second mean of your pre-calc is equal to 0, because that means that the two of them would be equal by some basic algebra. And the mean one minus mean two instead is greater than 0, would be the equivalent of our HA. So this would be your HO, your HA. After this, we can go ahead and mark down all of our information. Then we're going to compare it. It didn't give us an alpha again. So again, let's use that 0.05, and we'll see how close we are this time with our p-val. But we're going to plug all the information into the calculator. I'm not going to rewrite it all because it's right here, but just so you can see it, because I'll flip back and forth probably to grab these. Sample size for both groups is 100. The mean of 1 is 76. The mean of 2, or sorry, the standard deviation of 1 is 10. The mean of 2 is 71. The standard deviation of 2 is 13. Let's go ahead and start plugging it into our calculator. We're going to go to Menu, Statistics, Stat Test, and we're going to go to the two-sample t-test. We have the stats, not the data. So let's go ahead and go through here. Again, flipping back and forth. The first group is 76 and 10. So we have 76 with a standard deviation of 10 with a sample size of 100. And our second group is 71 with a standard deviation of 13. 71, standard deviation of 13. And it again has a sample size of 100. The only other thing it needs here is to know our HA. In this case, we're trying to show that M1 is bigger than M2. And remember, we don't like to pool our data. So we're going to leave that as no. We hit OK. And in this case, it says our p-value is 0.001317. So if we jump back to this guy, let's go ahead and bring that over since my last one was so ugly. In this case, our p-value was 0.001317. Again, this is less than our alpha of 0.05. And in fact, if we still chose a 0.01 or a 0.10, this would have been less than all of those. So again, in this case, we are able to reject that hoe. Now, what does that mean we can reject? It means we can reject that the average score in a prob and stat class and a pre-calc class are the same. We can actually move on to accept the alternative, and that's saying that the prob and stat does indeed have a higher average score than a pre-calc class would. So at the end of the day, you would write out that whole sentence. You would say, hey, we can reject that these two classes have an equal average, and we can move to accept the fact that a prob and stat class does indeed have a higher average score for its students than a pre-calc class would. That way, we have tied the original question back into our conclusion. We have all of our stuff written out on the page so they can see why we're rejecting and moving to accept. So it shouldn't be any confusion there. Make sure you write down your sample and you are done. Now, we have gone through all of these slides. This was meant to show you all the different types of things that we have covered this year, kind of thrown into one thing. There are a bunch of major topics that was not covered in this video. Namely, two of them that I can think of right off the top of my head is we did nothing to do with correlation, which is your two variable analysis. So I may make a second video that has us look at two variable analysis for a little bit, just so we can talk about correlation. Remember our correlation coefficient, our line of best fit, or our regression line with the y equals mx plus b, or in stats, it has the other formula of the b0 and the b1. But we'll go through and look through that. So correlation was not covered. Two variable was not covered. The other major topics we hit were our other distributions outside of the normal curve. So your geometric distribution, your binomial distribution. We didn't really talk about those either in any of this, other than when I slightly showed them on the screen with the normal PDF and CDF stuff. So those are just some stuff you may want to look into it in addition to the things we covered here. But as you can see, this question covered a ton of material. I hope you watched it all the way through. And probably tomorrow, look for another video that's going to be covering correlation a little bit so that you guys aren't completely in the dark on review for that. Well, guys, I hope this was helpful for you. And as always, stay fit, stay healthy, and have a wonderful day.